A warm welcome to today's webinar. We will get right into the topics. So today's webinar is going to be about saving energy with KNX weather station, and we're going to focus on the easy blind control for smart homes. We are your speakers today. My name is Bastian Elsner. I'm managing partner at Elsner Elektronik, and my responsibilities are mainly around sales and marketing. Next to me, I have my colleague Martin.
Hello, I'm Martin Speer and I'm delighted to be here today. As a product manager, I deal with the requirements for our products on a daily basis. As an interface to almost all parts of the company, I know the needs, advantages, disadvantages of our products. And as a long-standing system integrator, I'm particularly familiar with the user's perspective from practical experience.
Perfect. Thank you, Martin. All right. So this was just a quick introduction. So you have a face to the name. We will turn off the camera now. Some important information about today's webinar. So we're going to be live today. So if you have any questions on your mind, feel free to ask them as soon as they arise. We both are very much fans of interactive webinars. So we hope we don't just need to present you for 1 hour our slides about the weather stations, but also get some questions and remarks from your end. To do so, you can use the chat and question functionality on the top right-hand corners. We will do several quick breaks between the slides to check your questions and then go on to answer them. Let's get into today's topic. A first question. What do you notice about this facade? Also for this one, you can already give me some inputs what you're noticing. Maybe while you're sharing your input, I can tell what I can see in the first glance. So we have a huge heat input from the glass facade. This will be working like a greenhouse as soon as the sun is shining on the glass. Without a proper shading, we will require a very high cooling capacity of air conditioning for a building of this type. Also, there's no glare protection available, and we will definitely have a heat load in the rooms, which will lead to tremendous cooling costs. What is the other way? We can set up an automatic shading system with KNX. And in my opinion, this topic is becoming more important than ever. We have very pressing challenges like climate change, energy prices, CO2 savings, and also CO2 prices. CO2 prices are about to quadruple until 2027. So if we can save some CO2 in the maintenance of our buildings, it will transfer to cost savings within no time. So in summer, our aim is with automatic shading to reduce the direct sunlight and to reduce the need of air conditioning systems. Therefore, we will have a saving in cooling energy and we will have glare protection, which will increase the comfort of the users of the respective building. How we do in winter? We just do it the other way around. So in winter, we let the sun in on purpose in order to achieve passive solar heat gains. This will limit the heating energy this is required. Also, it's possible to have a better daylight control in order to save artificial lighting. Also, glare protection is possible in winter, of course. Our learning goals for today's webinar. So in today's webinars, we want to learn how to use the Elsner weather stations and their functions in a targeted manner. Next up, we want to show how to set up a simple but though effective facade control system in a minimum of time. Next up, we want to see how we can save and use energy with intelligent solar shading. Next up, in the last section, we want to have a look at how we can protect the drives from damage with safety function. There's some neat features integrated in our ETS applications, which we are really looking forward to show you over the course of today's webinar. Next up, the agenda. First up, we're going to start with the model comparison and the function overview. Next up, the thing that most people actually do wrong. It's about the correct installation of the weather station. I'm also looking forward to share some anecdotes and what might go wrong in the field with our weather sensors. Afterwards, we're gonna have a look how to set up an automatic shading system. Next up, the protective functions. We're also gonna discuss a little bit the advanced function within logic example. And that's about it for today's webinar. I will hand over to Martin now.
Okay, thank you. And as Bastian said, now we want to give you an overview of our weather stations, because we have many different weather stations, and so that's a very important thing to get to know them. The first product we want to show you is our wind dancer KNX. The main topics are it's a mechanical wind sensor. The GPS is optional. You have conventional applications, and a very important thing is that it's possible to make the power supply via KNX bus, so you don't need a 24-volt wire. The second one is our P04 KNX weather station in the middle, which is the smallest version of the KNX weather stations. The device does not contain any facade, automation, or logic functions. With this device, only the measured values can be sent to the bus, for example, to a building management system. The third one you can see in the middle is our Suntracer SL series. We offer these in the Suntracer SL, Suntracer SL Lite, and SL Basic versions. We can take a closer look at the differences between the individual models on the next page. The fourth one is our largest version. It's our Suntracer KNX Pro. This has facade automation for up to 12 facades. The special feature of the weather station is that it can detect the wind direction via ultrasonic technology. Okay, this is an extract of our comparison page you can find on our webpage. It's a huge PDF where we make a comparison, and this one is a short extract because yeah, there are many inputs in it. We divided our weather stations for 3 categories. So the first highlighted are only, or you need a separate facade control and a measuring sensor. We have a closer look on the next slide. The category 2 is facade automation that can only be realized via logics. And the category 3, these weather stations have an integrated facade control. Okay, so we go to the category 1, the P04 KNX GPS weather station. This one is without automatic and logic, so you need other devices. The second one on this page is our extension module, BX8. It can make a blind control for 8 facades, and it uses the values it gets from the weather stations, via KNX, of course. Okay, on the category 2, there are 2 weather stations. They're not very intelligent. They only have or make values from outer temperature, brightness, and so on. And you have to combine them with blind controls or blind actuators, which have their own automatic control, or for example, as mentioned before, with our BX8. In our category 3, we have our weather stations They're I would say the bigger ones. Sorry. This one, the wind sensor, as mentioned before, is a mechanical wind sensor. The GPS is optional, and if it has conventional applications. The next one is our KNX SL. So this one has a broad spectrum of applications. You can make as well as with the wind sensor KNX GPS, a very huge blind control. And of course, our Sun Tracer KNX Pro, as mentioned before, is the high performance weather station. Okay, another extension is our pyranometer. It's for the facade control depending on the solar energy. So if you don't only want to make the shading via brightness sensor, you can combine it with our pyranometer and get in touch with the global radiation and or the energy input. Okay, now do you have any questions about these individual models? Just write in the comments. Okay, thank you. We have two questions at the moment. The first one is, when do you use mechanical and when electric sensors? I would head over to Bastian to give the answer.
Perfect. Thank you, Martin. So to answer this question, I will just go back a couple slides to have the last overview. So the question has been, when do you choose a mechanical wind sensor and when do you use an electric one or an ultrasonic one? So the wind dancer KNX GPS has a mechanical wind dancer, and I would say it's very suitable for buildings that are not higher than 3 stories. Because one downside of a mechanical wind sensor is that it is struggling more in comparison to an electronic wind sensor to detect uplifting winds. So if you have a building that is, for example, G+5, so you have the ground floor plus 5 different floors, it is definitely recommended to not only have a mechanical wind sensor, but also to have some spread out electronic wind sensors to detect the uplifting winds. So to answer the question, when you require a mechanical or an electronic sensor, I would say a good rule of thumb is, do you have the need to detect uplifting winds that can damage your facade? If you answer this with yes, then you should go for an electronic wind sensor. If you answer this question with no, because the object you're trying to set up automatic shading is sort of low, so 3 stories, 2 to 3 stories, then the mechanical wind sensor is sufficient. The next question that arose is actually what a pyranometer is doing. So a pyranometer is measuring the global radiation. There are several countries in Europe, for example, Switzerland or also Luxembourg, that has set in their building code that a building according to a certain size is required to have a shading system according to global radiation if they want to implement an air conditioning system. So meaning, if you have a big commercial building and you want to implement an AC, you, in many countries like Luxembourg or Switzerland, you need to offer a system that takes global radiation values into account. I hope that answered the question. If not, feel free to ask more and we can try to give more context. Okay, I will move on to the next section of the webinar, and it's about the correct mounting of the weather stations. So the weather station can be either mounted on a wall or on a pole, and it is also adjustable via a joint. That also means if your roof does not have a perfect angle, you can switch it with the joint to realize the 90 90-degree angle from the wall the weather station is installed and the sensor itself. What's also very, very important is that we have a space of 60 centimeters below the weather station. On the next slide, here in this graphic, you can see the adjustable joint, and that's exactly what I meant. If you don't have a straight facade to mount, you can make use of the joint. This is very, very important to have an exact measurement and to not have any damages from moisture or other factors. All weather stations with the housing shape of the sun tracer SL, as shown in the photo, are mounted identically. So the weather stations can be either attached directly to a mast or on a roof with a clamp. The weather stations can also be attached directly to the facade or to the wall. But please always note that the weather station may be in the lee of the facade depending on the wind direction. Therefore, mounting on the facade only makes sense if there is shading on the same facade. Furthermore, the weather stations can be also mounted using a bracket, and the front of the weather station with the wind sensor must always face south. In addition, once again, similar as with the wind sensor, we need a clearance of at least 60 centimeters below the weather station. So this area below the weather station, we require the 60 centimeters, same as here and here. The Suntracer KNX Pro weather station must be mounted on a mast on the building due to the wind direction measurement. On the facade, it would not work. A mast extension and a suitable mounting material are included in the scope of the delivery. The next photo shows a complete mounting with a mast extension. Now, let's take a look at the installation and the settings. First up, I want to show you some cases on how to please not replicate it. Here we have the first error case, and there are several problems if you're trying to install a weather station like this. First up, you will have air turbulences due to the obstacles. That is also meant by the 60 centimeters of clearance that we need below the sensor. The next problem is that you're gonna have splash water in the rain and in the snow and in the winter, because if the rain is hitting on the metal concealer of the blinds, then this will also jump on the weather station and also probably bring moisture inside the sensor and will break it over time. Another issue is that the birds can sit wonderfully down there and can start picking on the heated parts of the weather station, and they might try to damage it. There's quite a simple solution for this. You simply need to have 60 centimeter of free space or clearance around the weather station. Let's have a look at a couple more not so nice installation examples. So here's the next one. It's kind of hard to see where the weather station is hidden, but it's actually here in the middle of the antenna. We have similar issues as in the last examples. We're gonna have air turbulences because of all the things that are around the weather station, and this will deny us a very exact wind measurement, and this will definitely lead to problems in this project. So here, once again, a quite simple solution. We require the 60 centimeters of clearance around the weather station in order to realize a good measurement. So another case, please don't install like that. You can see an air conditioner below the weather station, and you can see there is a very big ventilator. So the exhaust air are a very big fan in the AC. So this will lead to the problem that the exhaust air of the air conditioning system will distort the temperature and the wind measurement of the station. This sensor placed so close as something that is actually producing wind will not allow us for a correct measurement. The distance in between here is simply not great enough. So here you might say, if you have a device that is supposed to be measuring wind, you should keep everything away that is actually making wind, but that is not relevant to your shading itself. Therefore, the solution is quite simple. Install out of reach of systems that cause air currents or waste heat. Let's have a look at another example. So in this case, the customer had some issues with birds that were apparently sitting on the device and also put their trying to look for the right word. Please excuse the language. I cannot think of the correct one, but if a bird poops, the poop might fall down on the rain sensor, and this might trigger a constant rain alarm. So the customer expected this might help the issue because the birds cannot get close to the sensor. This does not really solve the issues with the birds, but also hinders the correct measurement, since this is casting shadow on the brightness sensors and can also cause air turbulences, so the measurement of the ultrasonic sensors might not work correct. Now that we have seen many cases on how to not do it, let's have a look at the mounting guidelines. And maybe another addition from myself, it's in many cases, it's not an issue of the sensor that the sensor is not working. It's mostly an issue of the correct installation of the sensor. That's why I cannot stress this enough, how important the mounting guidelines for the correct installation of the weather stations actually are. Let's have a look. Please take out the notebook and make some notes about this. As I said, cannot stress how important this actually is. So we need to have a distance of at least 60 centimeters below to the sides and to the front, to other elements of the sensor. The facade, the weather station needs to be in this orientation. So the facing needs to be south, and in the southern hemisphere, we need to be facing north. Next up, we need to have a vertical wall or a pole, and the supply cable needs to be looped as displayed before. So also you have a chance that the water is dripping down here and doesn't go anywhere else where it's not supposed to be going. That much about the installation. Do you have any questions about this part? We will take a quick break, have a look at the questions, and we will be back in a couple of seconds. Okay, so in order to avoid bird poop, this is actually something we don't hear too often. Sometimes we get remarks in our service department that there's a constant rain alarm being triggered. This can be an indication that there is some remains of a bird on the rain sensors, but there is not really a way that we can say to avoid this. In my experience, and also when talking to my colleagues in the service, this is an issue that does not come up too often. But if there's a constant rain alarm triggered, this might be an indication that there are some bird remains, some bird poop on the rain sensor that could trigger this. A ladder and some cleaning could already do the job, but there's also devices like scarecrows, for example, that are made for the use of roofs that are very shiny, and I've heard from other customers that can also help with this. There has been another question also. So what do I have to do if we have a sloping facade? Let me go back a couple slides to show you the adjustable joints. If you have a sloped facade, as you can see on the right-hand side of the graphics, you can make use of the wind dancer KNX in order to have this use case and to have the correct mounting. I hope that answered the question. Let me just have a look since there's a couple more questions are popping up right now. Okay, there has been another very, very interesting question about the difference of the NTP service. So that's meant by the network time versus the GPS module. This is actually something we're going to discuss over the course of today's webinar. So I won't go in too much detail over this and jump back into the presentation. So I don't see any recent more questions, so we can go on to the next topic. Next up, we want to see how we can install and integrate the automatic shading. Here we have a building overview where you can see different types of shading. So for example, in this house, we have used a wind dancer KNX GPS as the weather station. We also use the S4B10 230 volt shading actuators that we have in our portfolio. So those two devices we need to automate the shading system for this single family home. Let us start with the facade automation itself. I would like now to briefly introduce the individual functions of the facade control system. So first up, we have the brightness threshold value. Next up, we have the position of the sun. Next up, we have the shading setting. You have the options in the ETS to set the tracking with slat tracking or shadow edge tracking or a combination of both or even none. Also, you have the driving position and the extension and retraction delay, one of my favorite parameters when it comes to shading. Later in a separate section, we will have a look at the protective functions also. For example, the wind speed or the precipitation detection, aka the rain alarm. So we're going to take this example now, and as you can see, we have here the green blinds that we want to have a look in the first example. So this house is kind of simple. We have 4 different facades. So, and this is the case actually for most of the buildings. The solar shading has to be done for each facade and can be controlled separately. Then that's when we have the biggest lever. First up, we're going to have a look at the facade automation using the example of the south facade. We will watch a video in a second where I show how to set that up in the ETS. In the following video, we're gonna have a look at the wind dancer KNX GPS facade automation. To do that, firstly we're gonna go into the shading settings. Here, as you can see, you can configure up to 8 facades. For this introductory examples, we're just gonna use one facade for now that we gonna activate. Next up, we're gonna have a look at the facade 1 settings. Here you can see that we can select a brightness threshold value. We just make sure that 1 is selected. Also, you can put the percentage of the hysteresis when it's supposed to be activated. In the facade 1 settings, you can also have a look at the orientation. We have some pre-configured blocks of for the direction of the sun that can also be set in the facade 1 settings. It's also possible to activate the shadow edge tracking, slat tracking, or both in combination. For this introductory examples, we're not going to talk too much about this, since we're going to have some more advanced examples over the course of this webinar. Okay, as mentioned before, we need to make sure that there's a brightness threshold value selected, and we have 1 in the facade settings, so we're also going to activate the threshold 1 in the brightness section. Next up, we can have a look at the settings of the brightness threshold value that we have just activated for our facade 1. So our default value that we are proposing is 60 kilolux, and the hysteresis is put to a value in 20. Next up, we can have a look at the actions. So if the condition of 60 kilolux is fulfilled for 2 minutes, which we propose as a default value, but of course you can also set it to different values, but we're going to remain with the 2 minutes, the movement position 100 is triggered, meaning outside it's very bright, let the blinds down, and the slat position is to 75% closed. So what happens if this value is not active for a certain amount of time? Just imagine the case of a cloud is moving past your building and is lowering the kilolux value outside of your building. Here you can set this. So if this is happening for longer than 10 minutes, then you can trigger a change in the blinds. For this case, we don't want the entire blinds to move. That's why we didn't say yes, but we said no here, because we don't want too much action on the facade. We want a sort of calm picture. So that's why we only change the slat positioning, and there we put the value to 0%, which means it is open fully. This has a great lever for energy efficiency, because this makes you not want to use the light, the artificial light that you have inside the room, because you can let the light from outside inside the room because of the slat position. And once the cloud moved past again and the normal conditions are fulfilled for another 2 minutes, they just go back to the standard position. So what is happening if the brightness value after 10 minutes is not there anymore, and then after 30 minutes? We can make another position setting, which we simply put to 0 and to 0, meaning if for 30 minutes the threshold value of the kilolux is not reached outside, you can let the blinds up and let all the beautiful natural light in, and no need for artificial light, and we have a lever for energy efficiency. You have different options on how to send the information about the changes. You can either send them in the case of change, meaning one value is changing, or you can send them cyclically, and you can also change how often you would like to send them. We will just leave it for now in the case of a change, meaning the brightness value is changing outside of your building. In the heat protection parameter, it's possible to put a setting what is happening if a heat alarm is triggered. Heat alarm is triggered if you have a very high outside temperature, and then you can move the blind position to 100, meaning it's fully closed, and also the slat position to 100, which means it's also fully closed, meaning no light can come in from the outside, which helps to limit the use of climate devices and helps to save energy also. Next up, we have the blocking object that we can activate to block the facade. Let's have a look at the objects that we just created. So firstly, we have the status object. Next up, we have the movement position and the slat position. Movement position and slat position both will need to be configured with the actuator that you're using. And next up we have the blocking object. There's one super important object missing, and this is the wind alarm object, which we will set up in another video. Okay, perfect. I hope you enjoyed this quick video. Let's do a quick repetition on what we have just learned. So we discussed the brightness threshold value, the position of the sun, the shading setting with the without tracking slat, and with a mix of tracking and shadow edge tracking. We also discussed the driving position, the retraction and extension delay. And also an energy saving tip, only activate the shading that is hit directly by the sun. So for example, if you have a neighboring building that is casting shadow the entire day on your building, then there is no need to set a shading up at all, at least security functions in the evening example. Do you have some more questions about the facade automation? If not, we will go on to the protective function, because I've seen we are a little bit slow today and we still have a couple slides, but of course we will take time to answer all your questions. I will just have a quick look into the question section and see if something arose. Okay, we received some questions. Unfortunately, they go so deep into detail of the ETS that we will write them down and we will get back to you later on. We have your emails. I will just tell you, we'll get back via mail. So you know we will get back to you to answer your question. Okay, let's continue with today's webinar.
Okay, our next slides are about the protective functions. Here are some basics for setting the wind threshold value. Most important thing is that you need the details of from your shade manufacturer, for example, the wind speed, or the main thing is the wind speed, because sometimes you can find it in the data sheets, but mostly not, because they don't always have the same size. So ask your manufacturer of the shades to get to know the wind speeds. That's very, very important. Of course, to the basic settings, it's belonging the height of the shade and the mounting position of the weather station. On this page, we want to give you an overview of the wind speeds, how they are mentioned in some data sheets, or if you get them from your manufacturer, sometimes they are mentioned in Beaufort, and so probably you don't know, okay, for Beaufort, what is in a meter per second, so you can look at this table, and of course in the internet you have the comparison as well. Sometimes it's given in notes, not very often, but mostly in meter per second, sometimes in kilometer per hours. And so you can refer to this overview table. Okay, now I want to explain some things about the wind threshold and how it works. Okay. You can see the blue line, it's the current wind speed, and they're going up, and it goes over the orange line, and the orange line is the threshold value, which is set in the parameters of the ETS. You have the orange dashed line. Below the orange line, it's the hysteresis to avoid incorrect switching. And now you can imagine, okay, the wind goes up, it goes over the orange line, so over the threshold value, and the shades would go in the secure position. But we don't want them to go immediately in the secure position, because sometimes the wind goes up, down, and so we want to make a delay of a few seconds. We recommend to use about 5 seconds as the default, but you can manage it in the parameters of the ETS. Okay, then let's imagine the wind goes down under the orange line of the threshold, and if we don't use the hysteresis, then the blinds would go down or up, depends on what you set in the parameters. And always when the wind goes over and under the orange line, it would go up and down, and your customer would not be very friendly to you the next time. So you always you should use the delay time and the hysteresis. And there's another hysteresis. It's explained in the next slide as well, where you can set it. I go to the next slide. Okay. So as mentioned before, in this case, we made 7 meters per second and a hysteresis of 20%. And so here is the first delay time from 0 to 1, as I mentioned, 5 seconds. And from 1 to 0, we made 5 minutes. So that's this second delay time I talked about. Okay. And so it's a slightly smooth operating during the whole day, and the customer is happy about it. Okay, there's another protective function. So very important, the live telegram monitoring. We have a short video about it. It goes, or the topic is that the actuator should know if the sensor is still working. There are many cases that can happen. It doesn't work. The wires can be damaged or something like that, or the line coupler is not well parameterized. So there are many issues. And we have a short video for you.
In the following video, we will have a look at one of the most important security functionalities, and this is the live telegram monitoring that I'm going to show you how to set that one up, and we're going to do it with the example of a wind threshold value. So here we are in the general settings. We move down to the wind settings and we activate the use threshold 1. Then we go on the threshold value and we gonna set up the switching delay to 5 seconds, because we don't want just every small wind to be detected and we don't want to have movement on the blinds. So it has to be longer than 5 seconds in order to switch from 0 to 1, and for the other way around, for the switching delay from 1 to 0, we put a setting of 5 minutes. The switching output send, we put to change and periodically, and we would like to use a send cycle of 10 minutes. This is also our recommendation to do it that way. Next up, we can move on to our shading actuator, our KNX S4B10. Here we're gonna activate the output. We want to use the channel A as the channel for a blind. Then we go in the output channel. Here we can leave all the settings as they are for now. That's not really what we're interested in. We just want to have a look here, and we're going to use the block 2 as a wind block. Next up, we want to activate the monitoring, and we want to have the monitoring period to 30 minutes. For this use case, this is also our recommendation. I will explain in a second why. So next up we have to set the up command. So let's go back to the wind dancer for one moment. We have put up the setting of the wind threshold that we would like to send it cyclically every 10 minutes. Our actuator is receiving in this 30 minutes, meaning we have the chance of receiving per half an hour 3 values that are sent from the weather station to the actuator. If within 30 minutes no live telegram for the wind object has been transferred to the actuator, we will have the blinds go in the up command and drive into safety position. This is super important in case the sensor has a malfunction or something, so the blinds can go in a safety position. Next up, the last thing we need to do, we need to take the wind blocking object and put it on the wind alarm. Next up, we're going to go in our sensor and we take the output wind value and also put it to the wind alarm. And there you have it. That's how easy you can set up a live telegram monitoring with our wind dancer KNX GPS and our blind actuator S4B10.
Okay, I think these were very important information. So I know you get the video afterwards, so you can watch it twice or 10 times if you want. Okay, there are another protective functions. For example, the rain alarm. So the weather stations can detect rain, but it's set in the same way as the wind alarm. And you don't need it for every kind of blinds, but if you need, you can parameterize it in the ETS. Oh. Okay, and I heading over to Bastian.
Thank you, Martin. Okay, now we will have a look at the additional functions of our wind dancer. Let's get right into it. So we have the GPS settings to send date and time, plus we have the night detection. We have the calendar and weekly timers. We have the end and or logic functions, as you might know from some of our other weather station models. Next up, I would like to give you a quick logic function example, for example, for the interior lighting. So since our wind dancer has the brightness sensors, we can measure the brightness and control the outdoor lighting accordingly. So speaking, if twilight is detected, we can only switch the lights on when it's dark and at the right time. This can also save energy, and this is a very neat feature that can be done with a weather station besides the actual shading aspect. In the beginning, there has been another question about the NTP, and the GPS module. So the question was as follows. When do I need the GPS versus the NTP? So the NTP stands for the time and date that you can set up in the application. This is the way to do it manually. There's a couple reasons why it's actually very beneficial to go with the version that has the GPS module integrated. The first reason is the automatic location detection. So there is no manual setup needed. The GPS module allows the weather station to determine its exact position automatically. This is especially useful for installations when you need to do it quickly, or when the installer doesn't have the coordinates on hand. It speeds up the commissioning and it reduces the risk of errors. This is, I would say, a conform factor. Another one is that you need the accurate sun position calculation. Without this, you can cannot use many functions. For example, the sled tracking and the edge tracking is only possible with a GPS module, since the GPS module can calculate the sun path with very high accuracy, independent of any user input. This ensures optimal performance and avoids mistakes due to wrong or missing coordinates. So now you might ask, can I just not just enter the coordinates manually? Yes, it's possible for fixed installation and it's absolutely possible, but manual input is always prone to human error. And as you said, the level of automation, the degree of automation is quite lower in comparison because you're missing out on the sled tracking position and the shadow tracking position. This has a huge lever for energy efficiency because it has the connection to the daylight and artificial lighting usage that can simply be reduced. So in my point of view, it's always beneficial to go for the GPS version. Sometimes if there's like very tough budgets, then it might be okay to go for a version without the GPS module. And we are already at the end of today's presentation. And I thank you very much for the question, for your attention, and just some quick information. You will receive a feedback form after today's webinar to the email address on which you has registered to today's session. We are very, very much interested in your feedback because none of our webinar sessions is the same. We're always trying to implement the feedback to go deeper into the details that you are really interested in, and we cannot smell this. So it would be very, very good if you could just tell us in the feedback form. We always love positive feedback also, but the biggest learning lever we're having from the negative feedback. So kindly give us your brutal and honest feedback. That's exactly what we need to giving a better presentation the next time. Also, thank you very much, Martin, for being my co-host today. And from my end, goodbye.
Thank you for letting me join. And yes, from my side, goodbye too. And I think tomorrow is the part 2 of the webinar, so you can join. And if you have any further questions, as Bastian said, just write us an email. You can see it on this slide. We can still live here for a few seconds. Goodbye and thank you.